Okay, let's unpack this. We are diving deep today into the fascinating and sometimes incredibly frustrating world of AI making things up. You've shared a stack of sources with us, articles, research papers, notes, all focused on one critical challenge: AI hallucinations. Our mission for this deep dive is to cut through the noise and get to the core of the issue. Understanding why these advanced systems confidently fabricate information, the very real impact that has, and critically, what leading researchers and companies are doing to combat it. Think of this as your shortcut to getting your head around one of the biggest hurdles AI faces right now.
That's right. And the first key insight your source material delivers is that AI hallucinations aren't just, simple errors. They are fundamentally incorrect or misleading results that AI models, particularly large language models, present as fact. And often with surprising confidence. They aren't really accidental glitches so much as a side effect of how these systems are built.
A side effect. So it's not a bug, well, it's a feature we really don't like.
In a way, yeah. As your sources explain, models like LLMs are primarily optimized to produce plausible, coherent language. They base it on statistical patterns learned from these vast data sets. They're brilliant at predicting the next word in a sequence, making the text sound fluent. But crucially, this process doesn't inherently prioritize factual accuracy.
Ah.
They don't know facts like a traditional database does, nor do they possess like a true understanding of the real world.
Okay, so the core mechanism is predicting language plausibility, not checking truth. That explains a lot, actually. But why does that lead to generating things that are just flat out wrong? What are the mechanics behind this erroneous reality?
Well, it really stems from that probabilistic nature. When generating text token by token, essentially, word by word or part of a word, the model is always choosing the most statistically likely next piece.
Okay.
So if the training data is ambiguous, or if it has gaps, or if the model is prompted with something outside its core knowledge, well, that statistical likelihood can just deviate from reality.
And one wrong turn leads to another.
Exactly. An incorrect choice early in the generation process can cascade, leading to an entirely fabricated sentence or even a whole paragraph.
It's like autocorrect on steroids, confidently completing your thought with something completely wrong, but the AI just keeps building on that mistake.
That's a pretty good analogy.
Ah.
Errors compound. And another major contributing factor highlighted in your sources is the training data itself.
Right, the stuff it learns from.
Yeah. Any biases, inaccuracies, or gaps present in that data can be reflected and sometimes even amplified in its output. Your sources even raise the fascinating and slightly worrying concept of model collapse.
Model collapse, what's that?
It's this idea where training new models on data that was itself generated by AI could, over time, degrade the quality, diversity, and factual grounding of future AI generations.
Wow, AI teaching AI, and they all start forgetting what's real. That's a potential feedback loop you definitely don't want.
It's a significant long-term concern for sure.
Oh.
Then there are architectural limitations. Modern transformer models have what's sometimes called a limited attention window.
Okay.
Imagine writing a really long email. By the time you get near the end, it's hard to keep the exact wording of the very first sentences perfectly in mind, right?
Yeah, definitely.
Well, transformers can sort of struggle to maintain perfect coherence and factual consistency over very long generated passages, which can lead to fabrications based on earlier parts of the text or just losing the thread.
So they kind of forget the beginning of their own thought as they go.
To some extent, yeah. And algorithmic pitfalls contribute too. While they can mimic logical structures, current models often lack true, deep reasoning capabilities. And critically, they frequently exhibit overconfidence and poor calibration. They can be highly certain about information that is entirely false.
That overconfidence is precisely what makes hallucinations so dangerous for users. If the AI sounds authoritative, you're naturally inclined to believe it.
Absolutely. It's a major challenge for user trust and, frankly, safety. And finally, even how you prompt the AI matters.
How's
Well, ambiguous questions or requests for highly specific, obscure information the model hasn't seen much data on can push it towards fabricating plausible-sounding answers rather than just admitting it doesn't know. Your sources do note that providing more context in the prompt often helps mitigate this.
Okay, so the roots of hallucination are complex. It's a mix of the AI's fundamental design, the data it learned from, and even how we interact with it. But here's where it gets really interesting and why this isn't just a technical curiosity. These aren't abstract problems, are they? They have pervasive, significant real-world consequences. Why should you, the listener, really care about this?
Because these hallucinations are showing up in critical domains with really serious impacts. Take the legal sector, for instance. Your sources highlight these high-profile cases like Mata v. Avianca and the situation with Michael Cohen's team.
Oh, I remember reading about that.
Yeah, where lawyers submitted court filings citing completely fabricated legal cases generated by AI.
Fabricated cases, you mean like court decisions or precedents that just don't exist?
Exactly.
Yeah.
Complete with fake quotes, fake citations, just made up. This led to sanctions for the lawyers involved, obviously. And studies cited in your material show hallucination rates for LLMs on specific legal queries can be alarmingly high,
How high?
up to 88% in some tests.
88%? That's staggering. It's almost guaranteed to be wrong then.
It's a massive problem. The consequences are wasted time, ruined professional reputations, and potentially impacting justice itself.
And the risks must get even higher in fields like medicine.
Severely higher, yes,
Yeah.
with direct implications for patient safety. Your sources mention AI attributing false credentials to medical professionals, recommending treatments that are unsafe or inappropriate,
Yeah.
and even fabricating medical statistics or journal citations. One study found over 40% of medical journal citations generated by an AI were just fabricated.
40% fake citations. That could directly lead to misdiagnosis or really dangerous treatment decisions.
Absolutely. It moves from being embarrassing or costly to potentially life-threatening very, very quickly.
What about the business world? Is it happening there too?
Yeah. Oh, it's not immune at all. Hallucinations affect financial forecasting studies, showing around a 27% hallucination rate in earnings predictions.
27%.
Wow. Yeah, and risk models, which are crucial for financial stability and regulatory filings, are also impacted. Your sources cite error rates of like 14% in SEC filings and 22% in anti-money laundering reports traced back to AI input. Overall, hallucinations are contributing to strategic decision errors for businesses cited at 41%, and importantly, are eroding customer trust. That was about 33%.
So it hits the bottom line. Damages relationships, can lead to bad strategic calls. And you mentioned the human side again, that authority bias. We're kind of wired to trust things presented confidently by what seems like a knowledgeable source, which makes these confident AI fabrications so persuasive and dangerous.
Precisely. It really underscores that purely technical fixes aren't sufficient on their own. Educating users about AI's limitations and promoting critical thinking about its outputs is an indispensable part of the solution.
So, given the scale and severity of this problem across multiple industries, what is being done? How are researchers and companies actually trying to tame these hallucinations?
Well, your sources outline a kind of multi-layered approach, like a defense strategy tackling the problem from different angles. One key area is what you'd call data-centric strategies.
Okay.
This focuses on improving the quality of fuel the AI learns from using high-quality, fact-checked, and diverse training data to build a more reliable foundation.
Right. Like making sure the library the AI reads is full of accurate books, not, conspiracy theories and fiction presented as fact.
Exactly. That's a good way to put it.
Great.
Then there are model-level interventions. These involve modifying the AI models themselves. Techniques include regularization, which essentially stops the model from becoming too specialized on its training data, preventing it from fabricating when it sees something slightly different,
Okay.
and fine-tuning. That means retraining a pre-trained model on smaller, very carefully curated data sets, specifically designed to teach it how to be more factual or less prone to hallucination.
So trying to bake factual accuracy more deeply into the model itself, does this include trying to get the AI to signal when it's unsure? Can an AI truly know when it's lying?
Well, that's the goal of quantifying uncertainty, yes. To calibrate the model's confidence scores so they actually reflect the statistical likelihood of its output being correct. It's a significant technical challenge, but it's crucial for user trust. If it says it's 99% sure, you want that to mean something.
Absolutely.
And finally, there are output-level safeguards. These happen after the AI has generated its response.
Like having something else check the AI's answer, external fact-checking modules.
That's one approach, yeah. Your sources mention frameworks like Open Fact Check, designed to take the AI's output and verify its claims against trusted external knowledge sources. And perhaps the most important safeguard, especially in critical fields like law or medicine, is human oversight.
The human in the loop.
Exactly. Qualified professionals reviewing and validating AI outputs before they are used or acted upon is currently essential. That human in the loop remains critical.
So it's not just about fixing the AI, it's also about building systems around it and educating the people using it. And using specific prompts helps too, you mentioned earlier.
Yes, definitely. Clear, specific prompts are a user-side safeguard that can guide the model towards more accurate responses, reducing the chance it needs to just guess.
But beyond these current methods, what's on the horizon? What are the advanced frontiers researchers are exploring to build even more reliable AI?
One major frontier is something called Retrieval-Augmented Generation, or RREG.
Right, okay.
The core idea here is really powerful. Instead of relying solely on the knowledge embedded in its training data from months or years ago, the AI system retrieves relevant information from external authoritative knowledge sources at the time of the query, like right then.
Yeah.
And it uses that retrieved information to generate its response.
So it goes and looks things up in real time, like doing a very focused web search before answering.
Precisely. It grounds its response in verifiable information, often citing the sources it retrieved. This significantly improves accuracy and transparency.
That sounds like a huge step forward. Less reliance on potentially outdated or flawed memory, more on real-time fact-checking.
It is. It's a very active area. And there are innovative twists on RAG emerging, like debate-augmented RAG or deep RAG.
Debate augmented.
Yeah, this is where different AI agents within the system might debate the retrieved documents or even debate the text that the main AI generates. They try to find inconsistencies or potential fabrications internally before presenting the final answer.
AI arguing with itself to arrive at the truth. That's fascinating.
It's a clever approach to internal verification, isn't it?
Yeah.
However, RAG isn't a magic bullet. Your sources point out the challenge of hallucination on hallucination.
Ah, right.
If the retrieved information itself is wrong, or if the AI mishandles or incorrectly synthesizes correct retrieved information, it can still produce fabricated results.
So the garbage in, garbage out problem can still apply, even if it's retrieving live data. Makes sense. What else is being explored?
Another significant advanced frontier is Neurosymbolic AI, or NSAI.
Neurosymbolic. Okay, break that down.
This approach aims to combine the powerful pattern recognition and learning abilities of neural networks, the kind that power current LLMs, with the explicit knowledge representation and logical reasoning capabilities of traditional symbolic AI.
So, like combining that intuitive pattern spotting with hard rules and step-by-step logic.
Exactly. Think of the neural part providing the intuition and fluency, and the symbolic part providing factual constraints and logical validation. NSAI systems can use structured knowledge, like knowledge graphs, databases of facts and relationships and logical rules to check and validate the output of the neural network, basically ensuring it doesn't contradict known facts or violate basic logic.
That seems incredibly promising for preventing factual hallucinations. Like it has an internal fact checker built in based on logic.
It does. And a key potential benefit is enhanced explainability XAI. Because part of the system is based on explicit rules and knowledge, you can often trace the reasoning steps the AI took to arrive at its conclusion. It helps address that black box problem.
Which is huge for trust.
Absolutely. Your sources note NSAI is already being applied in areas like healthcare diagnostics, financial fraud detection, and autonomous systems.
So not just theoretical, but real-world applications already. What are the hurdles there? Sounds complex.
It is. Creating and maintaining the structured knowledge bases for the symbolic part can be complex and labor-intensive. Integrating the neural and symbolic components also presents computational challenges. But interestingly, your source notes some researchers see NSAI as potentially an antithesis to scaling laws.
Antithesis to scaling laws.
Meaning, suggesting that you might be able to achieve more capable and reliable AI with less massive data sets and potentially less computational power than simply trying to scale up neural networks indefinitely.
That would be a major shift in AI development, wouldn't it? Aiming for efficiency and reliability over just sheer scale.
A very compelling prospect, yeah. Now, maybe we should zoom out a bit to the broader landscape. Like, how do we even measure progress against hallucinations and what's happening with the regulation and trust?
Good point. Measuring something that's purely made up sounds difficult. How do you benchmark a fantasy?
It is challenging. Benchmarking hallucination rates is crucial for tracking progress and comparing models, but yeah, it's hard. You've got inconsistent definitions of what even counts as a hallucination and the risk of data leakage, where models might inadvertently be trained on the test data themselves, skewing results.
So the tests themselves have to keep evolving.
Yes, developing dynamic test sets is really important. Benchmarks like HellerLens and FaithJudge are emerging to try and standardize evaluation. And platforms like Vectora are maintaining leaderboards tracking the hallucination rates of prominent LLMs.
And what do those leaderboards tell us? How are the major models performing right now, based on your sources?
Well, recent data cited in your sources from late 2024 and early 2025 shows varying rates depending on the benchmark and the task, naturally. Models like GPT-4o were reportedly in the 1.5, 1.8% range on certain tests. Gemini models were looking better, around 0.7, 0.8%. Some Llama models were a bit higher, maybe in the 5.4, 5.9% range.
Okay, that's a pretty significant difference between models still.
It is, but importantly, your source notes. There's evidence that hallucination rates are dropping significantly year over year across the board. So concrete progress is being made, even if absolute zero isn't really achievable or maybe even the right goal yet.
What about regulation? Is the government or other bodies stepping in to mandate reliability?
Discussions around regulation are very active. A key debate, as your source points out, is whether to regulate AI development itself or primarily focus on regulating the use of AI systems.
Ah, the development versus application question.
Exactly. Your source highlights the perspective, championed by firms like, say, A16Z's, that argues for regulating use. They compare it to how the internet was treated in its early days. The argument is that existing laws can address harms caused by AI use, and regulating development too strictly could stifle innovation.
So regulate the application of AI and not the underlying tech itself. That seems pragmatic for encouraging development, but does it adequately address issues stemming from inherent flaws in the technology, like hallucinations?
That's precisely the tension in that debate. Your source also notes that private governance, through contracts, is playing a role. Companies are demanding certain reliability and accuracy standards from AI vendors they work with.
So the market is also trying to enforce some accountability there.
Yes, seems like it. Ultimately, though, building trust is paramount. Hallucinations directly erode that trust. Explainability, like NSAI aims for, and user education to counter biases like over-reliance, these are critical pieces of the puzzle.
And your source brings us back to the bigger picture with one final important question. Is hallucination a fundamental bottleneck for developing artificial general intelligence AGI?
The perspective shared is that, well, it likely is. If AGI is meant to possess human-like understanding and capability across a wide range of tasks, it really needs to be able to reliably distinguish truth from fiction. If a system can't do that, it's hard to see it achieving true general intelligence or trustworthiness. Resolving hallucination seems foundational for future, more capable AI.
So to wrap up this deep dive into the source material you shared, we've seen that AI hallucinations are a complex, multi-rooted issue. They're embedded in the very nature of how these probabilistic, language-focused models work, and they're having significant, sometimes dangerous impacts across critical areas of life.
And tackling this requires a really multifaceted approach, cleaning up training data, improving the models themselves with techniques like regularization and fine-tuning, building external checks, and exploring exciting new frontiers like RAG, which grounds responses in real-time retrieval, and Neurosymbolic AI, combining learning with logic.
Right. Progress is definitely being made, with recorded hallucination rates dropping, but challenges remain in benchmarking, finding the right regulatory balance, and ultimately building durable trust. This deep dive really reveals a rapidly evolving landscape where technical innovation, responsible deployment, and informed human interaction are all essential.
And maybe something for you to think about. If AI systems become significantly better at accurately signaling when they are uncertain about an answer, how will that change the way we interact with them? How will it change how much we rely on their information?
Yeah, will we finally feel confident trusting the information they present with high confidence? Or has the problem of hallucinations already planted a seed of permanent skepticism about AI's claims to truth, regardless of the technical fixes? Definitely something to think about.